Welcome everyone, and thank you for joining DoubleRadius for today's webinar with Cambium Networks. The topic for today is ePMP 3000, Maximize Network Performance with Gen3 MU-MIMO. And our guest speaker is Sakid Ahmed, VP of ePMP Business for Cambium Networks. Now, throughout the webinar, if you have any questions on the material, please enter them into your questions box, and this will allow us to refer to them during the Q&A portion at the end of the webinar. Also, make sure to pay close attention because we'll be asking some questions later on, and the first to answer those questions correctly will be the winner of a gift card. And then lastly, at the end of the webinar, please take just a brief moment to complete the survey that will appear on your screen. And with that, I'll turn it over now to Sakid Ahmed, VP of ePMP Business for Cambium Networks.
Thank you, Chad. Good morning and good afternoon to everyone who's joined the webinar. Super excited today to talk about ePMP 3000 in one of our very first webinars that we're doing for our North America customer base. You may or may not have heard about 3000. In either case, I'm hoping to go through this webinar and share some good information. Naturally, you'll probably have tons of questions following on, and as Chad mentioned, we will try our best to answer them. In case there are questions that don't get answered, I would highly encourage you to try to post on our community forums and present the questions to the DoubleRadius team as well, in case we can't get to everything. With that, we'll get started, and I will flip over to the next slide and start off by talking about what this ePMP 3000 is all about. I'll give a very brief history if you're not familiar with the ePMP platform and if you're coming and finding out about this for the first time. But fundamentally, we launched a ePMP 1000 series of products almost 5-6 years ago. That was what I would call our affordable platform that did GPS synchronization, specifically frequency reuse. It was a challenge in the WISP industry for a very long time that there wasn't a affordable platform that could do frequency reuse. And ePMP 1000 was our generation 1 product that broke through that barrier. With that frequency reuse and GPS sync, we also brought quite a bit of consistency and reliability and performance, higher number of subscribers, quality of service, a whole bunch of things. But fundamentally, the story around the generation 1 was to make sure that we address the topic of self-interference. And it's a mixed audience here, so I'm sure there's some people, this is old news, but what we've seen across the board is that a lot of times our WISP friends have used multiple access points in a tower, different frequencies, third-party RF armor type products to maximize the frequency use. So that's why the frequency use was a key focus of generation 1. As we move to generation 2, which is a popular product today and has been shipping for a while now, is the ePMP 2000. And in 2000, we took everything we did on the 1000 series and added beamforming in the uplink, narrow beams in the uplink so that we tackle the uplink interference. We added something called the dynamic filter that helped with neighboring adjacent channel interference. So that really packed a good punch in solving both self-interference and external interference. And of course, everything we did in the ePMP 1000, the scalability, QoS, all of that was also packed in the 2000. Naturally, the market has evolved and the speed became a big challenge, and everybody asked, hey, how do we get more performance out of our access point? Now, the foundation of building products that handle self-interference and external interference is still a rock-solid foundation for our strategy. But with that in mind, we started looking at how to maximize performance, and that's where this Generation 3 and ePMP 3000 comes into play. Needless to say, a point that I wanted to make is that across the board, the ePMP portfolio leverages your Wi-Fi-based chipsets, so 802.11. And therefore, you kind of track to the standard, IEEE 802.11 standard, and as the standard evolves, we leverage the economies of scale in the chipset, some of the benefits of the chipset, but then we rip away all the things that are bad about indoor Wi-Fi with contention and whatnot, and build a proprietary solution on top of that. The Generation 3 takes advantage of 802.11ac Wave 2, and that's a key distinction versus other products out there that capture Wave 1, in that it brings in the idea of multi-user MIMO. So what you see culminating in this Generation 3 ePMP 3000 is your frequency reuse with GPS sync, your dynamic filtering from the 2000, uplink beam steering that we had in 2000, and then this 4x4 multi-user MIMO concept. Along with that, what Gen 1 provided, which was the higher modulation, 80 megahertz channel, higher packets per second, overall better radio performance, and naturally adding more subscribers to the AP. What you see in the picture here is essentially the base station, the access point, and a 4x4 multi-user MIMO antenna, which is essentially two 90-degree sectors overlapping with each other. When we talk about value proposition at a high level, I want to highlight this, that why the multi-user MIMO becomes very important. Fundamentally, the multi-user MIMO means that you're grouping a couple of subscribers and you're able to do MIMO to two subscribers at the same time. Doesn't really depend on channel conditions and interference levels and things like that, because whatever you're getting today, if you're able to somehow meet the grouping requirements, pretty quickly you should be able to push traffic to two subscribers at the same time, so potentially doubling the performance that you see today. If you were lucky enough and get up-close subscribers, your interference levels were low, and we're starting to see this, that in some cases you will end up getting that higher modulation benefit too. So as you go through this, the chart we put here is essentially comparing to your existing ePMP 2000 type product. So MU-MIMO becoming the most likely scenario, getting 256 QAM higher modulation is a likely scenario, but it's not that common that you get the right SNR levels to hit this in all of your subscribers, maybe some up close. And then last but not least, 80 megahertz channel size brings another incremental step. We're trying to be as transparent as possible, because we deal with customers all the time, and we realize that in point to multipoint, 80 megahertz becomes a very unlikely scenario for an access point. At the same time, I will also say that as the networks evolve and you start building smaller cell radiuses and experiment with concepts of micro pop, 80 megahertz may be a viable solution in some of those cases. Okay, let's dig a little deeper on the value proposition and what we're talking about. The left side, right side of the slide kind of talks about the basic concept. There's no animation here or anything, but the best way to think about this is that at any given time, the AP is able to send downlink transmissions to two subscribers at the same time. There are essentially four transmitters on the base station, and the two 90-degree sectors overlapping with each other help with this simultaneous transmission. Behind the scenes, the subscribers have to be 11AC Wave 2, so it's the Force 300 series products. There has to be sounding mechanisms, which is essentially a process where the subscriber is sending information saying, hey, I'm capable. You have to have traffic available to go to both subscribers. But all in all, those combination of things are fairly easy to achieve, and you're able to get that MU-MIMO. Along with this, the other things we have is the beam steering, which will bring support for. The hardware support is there. We just need to update some software logic. The filtering is already in the radio built in. You have an SFP port in this product. The throughputs are getting pretty high with this base station, so we thought an SFP port would be important. Those of you that have been on ePMP for many years know that Spectrum Analyzer is a highly sought after functionality. The good news is the 3000 AP does have a built-in Spectrum Analyzer. So at any given time, you're able to see the environment from a spectrum perspective. There is also a nice little surprise right below the Spectrum Analyzer that will show you interferers and their MAC addresses and energy levels. So to some extent, you can see who else is on your channel as well as on other channels. We're yet to name this tool, but when you get your hands on a 3000, check out this tool, because we believe that the real-time spectrum analyzer combined with this tool makes for a powerful method to find out who is interfering on your channels. Wanted to highlight something else on the bottom right. There's a 1, 2, and 3 bullet points. The best way to think about that is that if you have a subscriber that is essentially a legacy subscriber, i.e. 11N, and I know I'll cover hot topics like backwards compatibility, forwards compatibility in a minute, but in point number 1 is essentially a subscriber that's an older language, older revision. There's no sounding capability. The AP will speak to it and just do MIMO like it would have with the 11N system. Number 2 mode is interesting because in number 2 mode, it's a subscriber that is capable of sounding, but it's not necessarily being grouped with another subscriber for multi-user MIMO. In that mode, you benefit from beamforming at the AP. The 2 overlapping 90-degree sectors give you additional 3 dB gain in the downlink by beamforming towards the subscriber. And that beamforming is happening because of the advantages of the AC Wave 2. This beamforming in the downlink is a little different than what we call the beam steering in the uplink. In the beam steering in the uplink, you actually have an active antenna that is creating narrow beams and dynamically switching them back and forth between different subscribers to create a narrower channel up in the uplink so that the 90/126 degree sector would not pick up as much interference. The beamforming here we're talking about is very much in the downlink. It has to do with 2 of the sector antennas directing the beams towards one subscriber. The last piece is leveraging that beamforming. You're able to now do downlink transmission in MIMO to 2 subscribers at the same time. So a little bit about how does it work. What you see here is an actual sector that is in a 90-degree sector with about 6 subscribers. They're all Force 300-25 dish product. I don't want to get into this too much, but I want to convey some high-level concepts here. As you can see, your subscribers are always going to have different distribution based on where you're trying to give them service. And what you see here is some things that says azimuth, delta, the degree angle, 48, 43, 11, 7, 34, 39. Fundamentally, what we are recommending is that if you want to achieve MU-MIMO, you have to have a minimum of 10 to 30 degree azimuth delta between 2 subscribers that will be groupable, or a 50 to a 70 degree delta between all this in a 90-degree, essentially, sector within that. So this requirement is relatively lax in our opinion. Finding a couple of subscribers that can be groupable becomes easy in a situation that we're seeing right here. So what is important to know is between customer 3, 4, and 5, you could potentially have other customers. There's nothing wrong with that. If you do, the chances of grouping customer 3, 3.2, 3.3, 3.4 right where my mouse is may be difficult. But as long as you have subscribers out here and out here in the 5, 6, then these guys can be grouped with those guys. The middle guys can be grouped with the bottom guys or the top guys. So when you think about your sector, always think in terms of, can I slice it up in 3 to 4 slices? And as long as I have subscribers in each slice, slice 1 can be grouped with slice 3, and slice 3 back with 1, et cetera, et cetera. Behind the scenes, the fundamental concept that we try to show you is that what you see here is the sort of the beam pattern and how we have a peak gain in one and a null in the other. This gain versus nulling is essentially allowing us to make sure both subscribers can hear that signal coming towards them. And what you saw in the earlier picture, representing here in green, says that customer 5 here could potentially be grouped with customer 4, 1, and 2. Take 2 seconds to back to the picture. Customer 5 is here. It can be grouped with these guys, but 5 cannot be grouped with 6 because these two are too close to each other in the azimuth angle. Today, the MU-MIMO operation is all based on this, what we call an azimuth metric, and it's all based on the separation and angle on the azimuth. We don't do anything on the vertical, but it's something we can look at in the future. Questions that will naturally come up because we talk about this MU-MIMO. Is it only Cambium antenna that supports it today? And the answer is yes. Today, in order to achieve MU-MIMO, we recommend that you use the sector antenna that comes with it. We are looking at other solutions for the future, split sector models and horn antennas, but at this point, this is those are a roadmap item. Okay, give you some numbers, the real world numbers. This always gets interesting. It's actually a pretty older software release. We've made some more improvements, but to give an idea of what you just saw on that sector, the top part here, customers 1, 2, 3, 4, 5, and 6. I forgot to change the name of the SKUs, but that's customer 6. You do a wireless link test, single radio, not doing a whole lot different, but the average downlink, average uplink is 93 meg, 26, 99, 27. This is, of course, in a 75-25 ratio. Single radio, nothing's happening. When I trigger MU-MIMO, what is happening is customer number 5 is being grouped with possibly 4, 2, or 1. And in this case, 5 and 4 are being selected at the same time, and we're doing a MU-MIMO link test. And here, the average throughput now for the AP becomes 169 downlink, and uplink doesn't change a whole lot, stays right around 25. When I group him with another subscriber, it's 176. We group him with another subscriber at 148. The best way to think about this is that as MU-MIMO comes in, as you have the data to transfer, your overall AP capacity increases. And this is where your AP capacity is the potential to double if you have the right conditions. Let's say if they were all in MCS9, not a lot of noise, then it clearly see a doubling. But here, as you go into the 2 subscribers, their individual conditions start making the modulation distribution a little bit more distributed. But the important point here is if you look at these numbers, 93, 99, 105, you start seeing 169, 176, 148. There's a substantial increase in the AP throughput. This is the most important value proposition that MU-MIMO brings to the table. Moving on to a very interesting topic of compatibility. This is a popular topic because of subscribers that are out there. Best way to look at this is that when we do compatibility, and I know this has been a bit delayed, and I'll talk about it in the next slide what the status is, but fundamentally, you want to take your ePMP 1000, 2000, upgrade them to a particular software release, as well as your 11AC or your 11N subscribers to the same release, and everything starts talking to everything. The reason you're doing this compatibility is fundamentally to navigate the migration. If you have a legacy network today, and you want to slowly upgrade it to a 11AC Wave 2 based solution, such as the 3000, you could upgrade the AP, but you can upgrade the SM slowly. They will all talk to each other, but as you replace the legacy SM with a new AC subscriber, you start getting that multi-user MIMO benefit and the benefits of the Wave 2 stuff. You don't have to do that overnight. You don't have to truck roll everything with this compatibility mode. And what we call backwards compatible is essentially a 3000 AP communicating to the legacy subscriber modules. What we call forwards compatibility is an ePMP 1000, 2000 speaking to a 11AC Wave 2 based subscriber. The best way to think about this is that everything talks to everything. I made a couple of commentary here. When you have an 11AC subscriber speaking to an ePMP 3000 or even a legacy subscriber, There is a 4x4 antenna now. There's two multiple receive chains. So there is a additional uplink gain improvement that you see just by replacing the AP. There are some other things under the hood that we enable, such as LDPC, that brings additional error correction in the uplink and downlink as you move into the compatibility. So as things start coming out, such as the software package for the ePMP 1000, 2000, we expect that you'll see a boost in your legacy network from a performance perspective. And this 10% throughput that we talked about in compatibility mode starts to go away and overcome by the gain improvement we see with the MRC combining as well as LDPC. Moving ahead, from a release planning perspective, this is always a fun, exciting topic. But what are we expecting? What do you get now? What do you get in upcoming releases? 4.3 is the official release that is getting programmed into all the products as they ship. So when you get your product, you'll actually see 4.3 on the radio. It has MU-MIMO support, the compatibility for the 300 subscribers. Today, it will come in with 20 megahertz support, SFP support, GPS sync, the spectrum analyzer, along with that other tool with the MAC SSID vendor ID. The beta support of backwards and forwards compatibility is built into the software. It's available, but we've decided to make this available via limited control beta. And the reason behind this is that anybody running large ePMP networks today, when you go to this compatibility mode, you are essentially taking your entire paying customer base and moving them to this new platform and talking a new language. We want to cook that. We want to cook that. We want to bake it with customers that are willing to try it. We are started our thorough testing. We'll find defects. We'll fix it. We'll make it stable. But we want to slow roll the compatibility to make sure that there are no major issues in the field. Within the 4.3 release, we have some challenges in uplink performance that we are trying to tweak and improve. QoS MIR is not going to be in this release. The 40 and 80 megahertz we blocked out. It's available behind the scenes, but we have a couple of issues we identified late in the game, and we thought that keeping this out of the release for now is good. And the backwards forwards compatibility is under control beta if you request it. And the good news is we've got a pretty robust software release plan. And as you've seen in the past, from the ePMP side of the house, we get things out very quickly. Release 4.3.1 will be very soon before the end of the year. So by the time you get the product, you'll have a next release in your hand. FCC DFS is pretty much all lined up. We're really just waiting on the grant. We're going to continue making some performance tweaks, fix some additional defects on uplink improvements, and we'll get more updates on the backwards compatibility. And more than likely, we'll open up the 40 and 80 megahertz in this release. The blue actually represents in planning, and I want to make a comment that dates and content are subject to change just because we are working very hard to bring features in, improve things. And a lot of times things come in and out. Things sometimes move out a week and a half. So just bear with us. As we move forward towards a tail of Q1, early mid Q2, February release, QoS becomes a key thing. Something around split sector support. We're also evaluating additional uplink downlink ratios. This is what was a request from 11N customer base for a long time, and naturally with additional bug fixes, performance improvements. Some exciting stuff down the road that we're considering as candidates around CIR, dynamic channel switching, traffic shaping, fast DFS, more or less representing a very powerful platform in 2000. So we've got lots of things we want to do. Just a matter of prioritizing, getting these done, and releasing to the customer base. What I like to call my 3,000 friends and family from a subscriber perspective. The top two you're already familiar with. This is what's coming out, even though there's a management Wi-Fi here. A future release that's built in will enable that. That will hopefully make a case for our CN Archer installation app. What happens after that is we've got this CSM, a 2x2 AP, IP67 ruggedized. that will work with horns from our friends at RF Elements on day one with the twist port adapter. This hopefully becomes a nice product placement for micropop type situations where you're looking for the higher modulations, possibly the wider channel bandwidths, and you want to do nice narrow horn antennas. Things that are in the pipeline, but we don't have a clear deliverable date, is a 20 dBi panel antenna. That is a move away from the dish design. It's in North America market, the 20 dBi from a weight volume perspective is going to be more attractive than a dish. But some may choose to go with the 25 dBi and not bother with the 20. But it may be a nice product that sits between a 16 dBi and a 25 dBi for a middle distance type situation. There is a small 13 dBi that I don't see a huge scenario for North America, but short hops, video type backhaul, CCTV backhaul, street light pole might be an interesting play. We are, no surprise here, but we are working on a MU-MIMO horn that will have the characteristics of horn antennas, yet to do MU-MIMO. It is not a long distance play. It's a lower gain product, and the idea behind it here is if you have very tight sectors that are shorter distances or whatnot, and you want to get the MU-MIMO benefit, then this is going to be the first in the industry for a MU-MIMO horn. Let's see, time-wise, we are just up at the 30-minute mark. I can see the questions thing popping up, so let me tell you that with that is the end of my presentation and my talk. And let's get into the questions from our audience. Chad, did you want to start going through some questions?
Sure. The first question is the tool to show interference service affecting, is the tool to show interference, is that affecting the SMs when it's running?
No, actually, Chad, I'm going to try to see if I can pull up the questions as well. Okay, maybe only you can see the questions, right?
Right.
Okay, that's fine. So the answer to that is no. The tool that I'm referring to, the 3000 actually has a dedicated chip that does the spectrum analysis and that tool that I spoke about. So there is no impact to performance on the SMs or the APs when that tool is running.
Okay. Next question is, this is in regards to the how does it work slide. It says the coverage scenario is very specific. If the customers are not clustered as you showed, how do you ensure that the lobes cover the area that we want?
If the customers, let me see if I understand the question. You're saying if the customers are not in that, could you repeat it, Chad? Sorry.
Sure. If the customers are not clustered as you showed, how do you ensure that the lobes cover the area that we want?
Okay. Let me see if I can tackle that question. So first and foremost, when you're deploying this product, your first task is to see your coverage plan. So you're going to look at your antenna pattern that we have on our antenna spec sheet. You're going to see that, okay, there's the bore side is in XYZ. The 3 dB roll-off is roughly around 70 degrees. So within a 90-degree sector, this antenna covers a 70-degree chunk with the highest gain possible. So you want to put your subscribers within that 70-degree beam width, right? That's how you're going to get coverage. Yes, you may have a guy or two that's on the side lobes. Maybe they're up close and they're going to get that, and that's all okay. So you would deploy this just like you would deploy any other system that you do today. Leave it to the radio, leave it to the software logic to figure out how it's going to group and do the MU-MIMO part. So what's going to happen is the wider the distribution, the more chances we have of able to group subscribers. But because it's just really two subscribers you're grouping, the 10 to 30 degree difference between two subscribers or the 50 to 70 is all we need. So when I show that picture, and I'm going to move back to that slide because this is an important topic. When I show this picture, you kind of see that, yeah, there's some guys here with some good gaps between them in the azimuth, but there's a couple of guys that are very tight. So as you deploy, first and foremost, worry about coverage, worry about getting the customer's connectivity. Then let the system take care of the MU-MIMO part of it. What I cannot guarantee you that if you have a very narrow sector and all of your subscribers are within 10, 15 degrees, then that's a difficult situation. But that is typically not the case whenever you're deploying a sector. Next question, Jay.
Okay, are we able to control QoS or some sort of rate limits on the SM?
Not yet. That is one of our highest priority features that we are looking at on the roadmap. The very next substantial release, right around end of January, middle of February, we hope to get QoS in there, where maximum information rate limit will be implemented.
Okay. Is the 3000 radio compatible with the same sectors and BSAs used with the 2000?
ePMP 3000 is compatible with the 2000 BSA, but not the sector. The whole premise of the 3000, going back to slides to show a picture, the whole premise of the 3000 is that you want to use it with this new 4x4 multi-user MIMO antenna. 2000 sector will not give you this advantage of multi-user MIMO. And we're officially stating that you need to use the new antenna with the new product.
Okay. And how will the 3000 compare with the 2000 with regards to interference?
Right. As I mentioned, the 3000 is built with all the same, let's say, the software secret sauce, but in addition, it also has the dynamic filtering. And then with the software update, you're going to be able to use the beam steering antenna from the 2000 for uplink advantages. So the interference tolerance of 2000 is built into the 3000. And then on top of that, we bring in multi-user MIMO, the higher modulations, et cetera, et cetera.
Okay, another question is, what are the physical interfaces between the 3000 and the Cambium antenna?
The physical interfaces, the best thing to do is we will publish a video that shows the assembly. There's actually an assembly video floating around YouTube as we speak. But what you see are the 4 connectors on top. Those 4 connectors are your interfaces to chain 0, 1, 2, and 3. There are 4 antenna chains. Then when you pop open the bottom cover, you'll see 3 other connectors. 2 are for the beam steering antenna and 1 for the GPS puck for the external GPS antenna. But I would highly recommend that take a look on YouTube. There's an unboxing video, and we have a really nice assembly video getting its finishing touches that we will post as well. Next.
Next question is, what are the max output powers for each stream?
Max output power on each stream is, I think our combined is up to 32. I think 26 is where we are, max output power per stream. I would refer to the spec sheet, but if I'm not mistaken, I think 26 is per chain, essentially.
Okay. Next question is there EAP support and are MIR attributes supported?
So 2 different questions. I guess EAP as in from an authentication mechanism, and MIR. I'll punt the EAP question to Dimitri, who's on the call. But MIR-wise, as I mentioned, it's on the roadmap. It is one of our highest priority roadmap items. So this will be in the subsequent main release. EAP-wise, I believe we support it today. Chad, I'm not sure if you can switch panelists, but Dimitri just confirmed, yes, EAP is supported today. MIR is on the roadmap.
Okay. What is the minimum azimuth separation needed between clients to trigger a MU-MIMO?
It's 10 to 30 degrees or 50 to 70 degree. So if you look at a 90-degree sector, as long as a couple of subscribers have a minimum of 10 and up to 30 degrees on one side of the 45, and then on the other side between 50 and 70 degrees, you can trigger MU-MIMO.
Okay. And last question. What extent of beam steering can you achieve? What is the extent of the beam steering that you can achieve?
Let's break that down in two parts of the answer. So a refresher on this is that the 3000 does beam forming in the downlink, which is essentially the bottom right-hand corner. You see these two patches. Those are two 90-degree sector antennas that overlap with each other, and they're forming the beams towards a subscriber, two subscribers at the same time, able to do the MU-MIMO. Beam steering is what we like to distinguish the uplink behavior, where in 2000 we have a beam steering antenna. The question of what extent, in the ePMP 2000, the sector antenna was a 90/120 degree sector antenna, and the beam steering antenna was only for uplink, or is only for uplink. And what would happen is our AP would decide when to use the sector antenna for uplink or when to use the beam steering antenna. In the beam steering antenna, we create dynamic narrow beams. If I'm not mistaken, they're somewhere between 20 to 25 degree angles. So that's the beam width that we're creating, and that's what's being triggered towards a particular subscriber when we decide that that subscriber will benefit by using beam steering in the uplink as opposed to full-fledged 90/120 sector. Hope that answers the question.
There's actually, there's a number of other questions here. I'll see if I can get to a few more here before our time is up. Let's try this one. What CINR or SNR is needed to reach NCS 8 and 9 in a 20 meg channel?
Great question. I believe, and please, I need to double check this with our specifications, but somewhere right around MCS 9 is a 34 to 36 dB CINR or SNR. And then as you go to 64 QAM, it becomes a 30 dB requirement. What we will do, Chad, is please, so what I encourage the audience to do is frequently come back to the Cambium forum knowledge base. We will post tables and information that give you the guidance on the CINR. But I'm very glad somebody asked that question, because that is basically the foundation of being able to build a good network.
Yeah, there's a lot of great questions, and I think there's so many here that we can't get to all of them, but I'm going to do just a couple more before we ask our questions for the gift cards. And then what we'll do is we'll make sure that everyone who's asked a question here, that if we didn't get to it online, that we will answer them specifically offline. So we'll see if we can get a couple more in here, though. Will the MU-MIMO automatically assign grouping?
I was going to say, this is Stump the Presenter, last two questions that you're probably looking for the hardest ones. The answer to that is, this was an easy one, yes.
Okay, easy enough.
So the next question, yeah, go ahead.
Does the ePMP offer radius authentication or radios similar to the PMP line? PMP-MI line.
Yeah, it sounds like it's a new ePMP customer. So the answer is yes, it does.
Okay. And then we'll do this one last question here before I ask a couple of questions of mine. Are there plans for sectors that are more narrow, 60 or 45 degree?
Yes, there is. We absolutely appreciate the need for narrower sectors. So we are looking at possibly a 45-degree 4x4 MU-MIMO sector. You'll get more on that later down the road, but definitely that. And then the dual horn that is lower gain, but good for a micro pop type situation. That's a 60 degree as well as a 90. That is going to come out early next year. And then, of course, the CSM product, the connectorized 2x2 version of the AP. Sorry, let me just move ahead. Maybe seeing the picture will help. The 2x2 version will work with the RF elements, horn antennas. So those will be narrower sectors by default.
Okay, great. I appreciate you taking all those questions. And like I mentioned, we will make sure to answer. There's just too many questions to go into right now, which is great. People are really listening and asking great questions. We'll get back to everyone individually if we didn't catch you here. So a couple of questions just for some fun that I have here. And to answer, just enter your answer into the question pane. And the first person who answers this correctly will get a gift card out to you. So when changing from the ePMP 1000 or 2000 to the ePMP 3000 with MU-MIMO, you can get up to potentially how many more times throughput? And we'll take a rounded number on here. All right, looks like Nate Bell was the first one to answer. So we'll make sure we get that out to you, Nate. And then we have one other question here for you, which is, ePMP 3000 is backwards compatible as long as these legacy devices are updated. Go ahead and answer. So not a yes or no question, but as long as what devices? Hint, they're on the side of a client premise. SM, there you go, Jay Stewart, you got it. Okay. So that ends our time here together. Thank you, everyone, for participating with a lot of great questions. And this recording will be made available shortly. And we will get back to you with any of those questions that we weren't able to answer here online. And until next time, thank you very much and have a great day.